Hello students, welcome to the math class. Today we are going to discuss your chapter 5, Introduction to Euclid's Geometry. The word geometry comes from the Greek words geo means the earth and metrein means to measure. Geometry appears to have originated from the need of measuring land. From the ancient time itself, people were acquainted with geometry. Though they didn't know about the concepts of geometry, but they were using geometry in some way. Let it be in the ancient Egypt era, let it be the era of Harappa or Mohenjo-daro. They used to construct different kind of buildings, drainage system. They were used to build many kind of land platforms. So everywhere they are using geometry because they need to measure something, they need to construct something. So they were involved with geometry though they didn't know it. You see, today itself we are using geometry in various cases. That's why geometry is one of the important parts of day-to-day life. And we can say that it's a very important part of mathematics. In this chapter, we are going to discuss the Euclid's axioms, postulates and their utilizations. Initially, everyone was thinking that geometry is revolving around the concepts given by Euclid. And with the flow of time, many other mathematicians came and geometry has seen many changes. Students, let us discuss Euclid's definitions, axioms and postulates. Okay? Before going to that, let us discuss about some terms related to this chapter. Fine? Students, as given in your page 1, whenever the river Nile overflowed, it wiped out the boundaries between the adjoining fields of different landowners. After such flooding, these boundaries had to be redrawn. For this purpose, the Egyptians developed a number of geometric techniques and rules for calculating simple areas and also for doing simple constructions. The knowledge of geometry was also used by them for computing volumes of granaries and for constructing canals and pyramids. They also knew the correct formula to find the volume of a truncated pyramid, as you can see in the diagram given on the first page of your chapter. Okay? So students, with the flow of time, the world has been seeing many changes in the field of mathematics. In case of geometry, so many mathematicians were there who tried to build up different concepts, and Euclid is one of them. The Greek mathematician of Euclid's time thought of geometry as an abstract model of the world in which they lived. The notions of point, line, plane and so on were derived from what was seen around them. From studies of the space and solids in the space around them, an abstract geometrical notion of a solid object was developed. A solid has shape, size, position and can be moved from one place to another. Its boundaries are called surfaces. They separate one part of the space from another and are said to have no thickness. The boundaries of the surfaces are curves or straight lines. These lines end in points. So let us discuss this and observe how they go. As described or as explained, a solid has shape, size, position and can be moved from one place to another. Its boundaries are called surfaces. That means let us take a solid as a cube. So this is a cube and according to them, these surfaces, these are the surfaces, the end point of the solid. These are the surfaces. So a cube has 6 surfaces, that is 1, 2, 3, 4, 5 and 6. Total 6 surfaces. And let us draw another solid, that is a sphere. So this is a cube which has 6 surfaces and the surfaces are joined to each other with a straight line. Like this surface is joining this surface at this straight line. So this is called the edge of the object. So this is a straight line. In case of a sphere, suppose this is a sphere, it's a 3D object. The surface of the sphere is circular in its construction and the edge, that means the edge is curved. In this case the edges are straight and this is curved. So this is the definition. The boundaries of the surfaces are curves or straight line. The boundaries of the surfaces are straight line or curves. These lines end in points. So these lines end in points. See, this is an edge, this is an edge, it is ending at a point. So in this point, three different edges are meeting each other. So these are the concept they were following. Again, it is said that the three steps from solids to points: solids, surfaces, lines, points. In each step we lose one extension, also called a dimension. So a solid has three dimensions. A surface has two, a line has one, and a point has none. Let us observe that. It is said that a solid has three dimensions. That means in this case, this is a solid, this is a cube. It has three dimensions: length, breadth and height. It has length, breadth and height. Students, now this is a surface, this is just a square. In case of cube, the cube has 6 squares, 6 surfaces. So each surface is having two dimensions, only length and breadth. Length and breadth. Same goes with your rectangle. Length and breadth. In case of square, we call the length and breadth they are equal, so they are called the sides. In case of rectangle, it has a length and a breadth. Okay. Same, when we go for surface having a curve, we can go for a circle. A sphere is a three-dimensional object and a circle, it is a two-dimensional object. Okay. Now what happens with a straight line? A straight line or a curved line. A line has only one dimension, it has only length, isn't it? We can measure and find out the length of the line segment as well as this curve, isn't it? But what happens in case of a point? So this is a point. A point has no dimension. Okay. So a solid has three dimensions, a surface has two, a line has one and a point has none. Okay. Now Euclid began his exposition by listing 23 definitions in book 1 of the elements. A few of them are given in your book. Let us discuss all of them. The first point says that a point is that which has no part. The first point says that a point is that which has no part. Exactly. It has no part. The point has no part. Second point says a line is breadthless length. What is a line? It is a breadthless length. So this is a line. It's a straight line which has no breadth. It has only length. Why? Because it is being constructed with a combination of multiple points. When points are gathered together or they are being placed together one by one, they construct a line. Same thing goes with a curved line. A curved line is a curve having points arranged in a curvical structure. Then third point says that the ends of a line are points. Exactly. As I have already told you, the line is nothing but the combination of points. So the end points, they has to be points as well, isn't it? The fourth point says that a straight line is a line which lies evenly with the points on itself. What does it mean? It says A straight line is a line which lies evenly with the points on itself. That means the points, they can, if they lie like this, when I join them, they give me a curved line. But in a straight line, the points lie on itself evenly. That's why a straight line is a line which lies evenly with the points on itself. All the points lie on itself. In case of a curved line, the points are on itself, but they are not evenly arranged. They are not evenly arranged. So fifth point says that a surface is that which has length and breadth only. Exactly. As previously discussed, we constructed two different surfaces, a square and a rectangle having two dimensions, a length and a breadth. Next is the edges of a surface are lines. It was also previously discussed, as we had seen clearly that the surfaces meet at a line. Okay. The last point, the seventh one, it says that a plane surface is a surface which lies evenly with the straight lines on itself. What does it mean? A plane surface. Okay. Let us observe it. See, this is a plane surface. Okay. Because the lines, they lie evenly on itself. They are not going anywhere else. This is a plane. The lines lie on itself. That's why it's a plane surface. So, students, if you carefully study these definitions, you find that some of the terms like part, breadth, length, evenly, etc. need to be further explained clearly. For example, consider his definition of a point. In this definition, a part needs to be defined. Suppose if you define a part to be that which occupies area. Again, an area needs to be defined. So, to define one thing, you need to define many other things, and you may get a long chain of definitions without an end. For such reasons, mathematicians agree to leave some geometric terms undefined. However, we do have an intuitive feeling for the geometric concept of a point than what the definition above gives us. So, we represent a point as a dot, even though a dot has some dimension. Students, a similar problem arises in definition 2 above, since it refers to breadth and length, neither of which has been defined. Because of this, a few terms are kept undefined while developing any course of study. So, in geometry, we take a point, a line and a plane as undefined terms. The only thing is that we can represent them intuitively or explain them with the help of physical models. Starting with his definitions, Euclid assumed certain properties which were not to be proved. Let us discuss about these things. Okay? Students, before going to the properties, let us discuss certain concepts. First one is your sentence. What is a sentence? It's a combination of words having a certain meaning, isn't it? For example, I am a boy, he is a girl. These are the sentences. But what is a statement? See, when you go to a police station, the policeman over there, he records the statement. He tells us to give our statement. He doesn't tell that give your sentence. So why does he say give your statement? Because statement can be true or false. It has to be verified. The sentence, when verified, is called a statement. So before verification, it is called a statement. Then what is an axiom? It is a truth. The statement which is verified as true. The true statement is called an axiom. Postulate and axiom are just like brothers to each other. They are family members. They relate to same thing, but what is the only difference is that axiom relates to all kinds of mathematical concepts, where postulate it deals with geometry only. Okay. So as per Euclid, these all are universal truths and he divided them into two types, axiom and postulate. Fine. So I hope you understood about axiom and postulate. Axiom deals with mathematics, but postulate deals with the universal truth which are included in geometry only. So if I say that half plus half is equal to 1, it is a universal truth, but it deals with mathematics. Geometry is also a part of mathematics, but for specifically geometry he included postulates. Suppose I say that a line segment is a part of line. This is a universal truth. So this comes under postulate. Okay. So students, let us discuss some of Euclid's axioms, not in his order. Okay. As given in your book, there are 7 axioms and we will discuss one by one. The first axiom says that things which are equal to the same thing are equal to one another. What does it mean? Things which are equal to the same thing are equal to one another. Let us discuss. So students, if I say A is equal to C and B is equal to C, here we have a value C which is equal to A as well as B. That means it clearly says that A is equal to B. Okay? Things which are equal to the same thing, things which are equal to same thing are equal to each other. Okay? Things which are equal to same thing are equal to each other. Let's go to the second axiom. It says that if equals are added to equals, the wholes are equal. Let us check it out. So students, if I say A is equal to B and M is equal to N, so when I add them, A plus M is equal to B plus N. So we clearly see that when equals are added, the wholes are also equal to each other. That is the second axiom. If equals are added to equals, the wholes are equal. Let's go to axiom number 3. So it says if equals are subtracted from equals, the remainders are equal. So if A is equal to B and M is equal to N and we do the subtraction combinedly, so A minus M is equal to B minus N. That means when equals are subtracted, the wholes are also equal, isn't it? So if equals are subtracted from equals, the remainders are equal. Let's go to the fourth axiom. It says things which coincide with one another are equal to one another. Let us see it. So students, I have two 500 rupees notes. Okay. So the axiom says that things which coincide with one another are equal to one another. You can clearly see that these 500 notes are rectangular in shape. Let's put these notes one over another. Now you can see that it is giving us a feeling as if it is a single note because they are coinciding with one another. That means one is hiding behind another. When they coincide properly with each other, they are hiding behind one another and they are giving us a feeling as if it's a single note. Why is it so? Because they are equal to one another. That's why when they coincide, okay, that means if they are equal, they can coincide with each other. That means they can stay exactly over one another. Okay. The next axiom says that the whole is greater than the part. Obviously, you take a chocolate, have a bite. the remaining thing that is in your hand is a part of that chocolate, and a part of it is inside your stomach. That means the whole is greater than the part. That means you have a chocolate and you have a bite of that, so the remaining thing is obviously lesser than the whole chocolate. So it's a universal truth. It is true for everything in maths as well. Suppose I draw a line segment, let us see it as AB. So if I put a point C over here, so it gives me another line segment AC. So I can say AC, which is a part of the line segment AB, is smaller than AB. That means AB is greater than AC. The whole is always greater than a part. It's a universal truth. Okay. The next axiom, axiom number 6, says that things which are double of the same things are equal to one another. What does it mean? Things which are double of the same thing are equal to one another. That means if I say A is equal to 2C and B is equal to 2C, it implies that A is equal to B, because A is also double of C and B is also double of C. That means A has to be equal to B, which is a universal truth. Okay. So let us discuss this axiom using mathematics. Suppose I have a variable x which has a value 2, and we have two other variables A and B. Okay. So if I say A is equal to 2x and B is equal to 2x, let us put the value of x and find out the values of A and B. So A is equal to 2 into x, that means 2, that is 4, and B is also equal to 2 into 2, that is 4. So you can clearly see that A has the value of 4 and B has the value of 4, that means A is equal to B. Okay. The seventh axiom says that things which are halves of the same things are equal to one another. Let us discuss. It is just the opposite of the axiom number 6. Okay. So if I have a variable called x as 2, fine, and if I say that A is equal to x by 2, that means half of x, and B is equal to x by 2, that means half of x. So what should be the value of A? That is half into 2, that is 1. Half into 2, that is 1. That means A is equal to B. Okay. Things which are halves of the same things are equal to one another. Fine. Students, let us discuss Euclid's 5 postulates. Why they are called postulates? Because they are axiom related to geometry. Okay. So the first postulate says that a straight line may be drawn from any one point to any other point. Okay, let us discuss it. A straight line may be drawn from any one point to any other point. In one of the axioms, we have found out that given two distinct points, there is a unique line that passes through them. Okay, so a straight line may be drawn from any one point to any other point. Suppose there are 2 points. Okay, so I can draw a straight line from this point to this. Through this point, multiple straight lines can be drawn like this. Through these 2 points, let the points be P and Q. Through the points P and Q, at point P we can draw multiple lines, at point Q we can draw multiple lines. But there is a single line that is joining P and Q. Suppose this is P and this is Q. This is a straight line. Okay. I can join these 2 lines to have a straight line or a part of line, that is called a line segment. Okay, I can have multiple curved lines. Okay, I can draw multiple curved lines, but I can have a single straight line which joins the point P and Q. Okay, postulate 2 says that a terminated line can be produced indefinitely. Okay, what does it mean? Let us discuss. Suppose there is a point A and a point B and we are drawing a line segment. Okay, so now A and B are the 2 points of the line segment, but this line segment can be produced indefinitely in both directions to give us a line. So previously the line was terminated at A and B, but the line segment can be produced in both the way to get a straight line. That means AB is just a part of a straight line. Fine. Postulate 3 says that a circle can be drawn with any center and any radius. Let us check it out. So this is a point. I take any radius, so I can construct a circle like this. I can have another point with a smaller radius, so I can draw another circle like this. So that's the postulate says a circle can be drawn with any center and any radius. What about postulate 4? Postulate 4 says that all right angles are equal to one another. Let's check it out. See, these are two right angles. They have sides of different length, but the value of the angle is 90 degree. So the right angles may differ in their sides, but the value of the angle included by both the sides is same, that is 90 degree. So all right angles are equal to one another. So postulate 5 says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Isn't it a bit critical to understand? But do not worry, let us discuss and clear it very well. Okay? So it says that if a straight line falling on two straight lines, let us draw two straight lines first. Another straight line falls on it. So there are three straight lines. Line L, line M and line N. So line L falls on line M and N. Line M and N are separated from each other with a distance. So when line L falls on line M and N, intersecting both the lines, suppose at point O and P, it creates four interior angles. That means on line M at point P, line L forms a linear pair. What does a linear pair means? A pair of angles which is being constructed over a straight line. So these are linear pair. So this is another pair of linear pair. So what is the value? That is 180 degree. Over here the sum of these two angles is also 180 degree. The postulate says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Two right angles means 90 degree plus 90 degree, that is 180 degree. So in this case, it is clearly observed that these two angles are acute angle because they are less than 90 degree. So sum of these angles has to be, suppose this is angle A, this is angle B, this is angle C, this is angle D, Angle A is less than 90 degree. Angle B is less than 90 degree. So sum of angle A plus B has to be less than 90 degree plus 90 degree, or A plus B is less than 180 degree. So the postulate says that if taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on the side on which the sum of angles is less than two right angles. That means if these two lines, line M and N, are produced indefinitely, let us produce them indefinitely. So if I produce them like this, so it says that they meet on that side on which the sum of angles is less than two right angles. So in this case, because A plus B, angle A plus angle B is less than 180 degree, so when I produce these lines towards the same direction, they meet at this point. Suppose this point is X. So now line M and line N, when produced in the direction of the angles which sum are less than 180 degree, meet at a point X. Clear? So in this case, see, C and D, let us concentrate on angle C and angle D. As angle A plus angle B is less than 180 degree, angle C plus angle D has to be greater than 180 degree. Okay, so they are going away from each other. They are going away from each other. If we produce them, you can clearly see that they will never meet with each other. If I produce them in this direction, they will never meet with each other. Okay, so students, today we have discussed many concepts about Euclid's geometry. Those are the axioms and the postulates. In our next class, we will start discussing about the examples given in your book as well as the exercises. Okay? Till then, revise all the concepts. Keep practicing mathematics, because more you practice, more you will be strong in your mathematics. And always remember to smile. Keep smiling. Take care. Thank you.